This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
Hi, this is Stefan Tilkov for Software Engineering Radio. Today I'm sitting down with Michael Nygard. Michael is widely known for his presentations and writings about software and system architecture as a contributor to the books Beautiful Architecture and 97 Things Every Architect Should Know, and probably most notably for his phenomenal book Release It, which was the topic of episode 134 of this podcast. These days, Michael works as an architect at Cognitect. Our topic today is Clojure in practice, and we'll take a look at how this Lisp-like language is being used in real-world projects. So Mike, welcome to the show. I'm really happy to have you with us here. Most of our listeners know you from your work in the areas of architecture and stability patterns and resilient systems, but today we're going to talk about Clojure. Can you tell us a little bit about how you got into the Clojure world and what interested you?
Absolutely. It started around 2007, I think. I had been working in Java for a long time, since 1995, and was, like a lot of people, I think, beginning to feel a little stagnant with Java the language, but reluctant to discard Java the ecosystem and all the libraries and the vast amounts of code that were available. So I started looking at some of the JVM languages, and first I went to Scala. I was attracted by the parser combinator library in Scala, and it was a completely new way of writing parsers to me. So I moved into Scala and worked in that for about 2 years when I saw Stu Halloway give a presentation on Clojure. And at that time, it absolutely floored me. You know, like many people, I'd been exposed to Lisp before and sort of had this feeling that, you know, it was a nice academic thing, but not something a programmer used in the real world. And Stu showed me that indeed it could be a real world language. And I pretty much immediately dropped Scala and started moving into Clojure.
Okay. Maybe before we start talking about more detail about Clojure, what was it actually that frustrated you with Scala? Because I know many people like Scala and are very happy with the language.
It wasn't so much that I was frustrated with Scala, although I certainly did feel like I had not mastered the type system well enough to make it work for me. I was working for it. But it was more that the clean expression of ideas in Clojure appealed to me. So it was a move toward, not a move away.
Mm-hmm. Makes sense. So can you give those of our listeners who know nothing about Clojure a brief introduction?
Certainly. As I mentioned, it's a Lisp, so it's in the family of parenthesis delimited languages rather than curly brace delimited. That's the most obvious thing on the surface. What it really provides under the covers, though, is a language and a library that strongly favors immutable data structures and very precise control over how you manage your state. And so it makes a nice language for building multi-threaded applications. And in general, there are all kinds of concerns about mutation that you run into in a typical OO program that you simply don't have with Clojure. If I have a map, I can rely on changing that map in whatever way necessary because I'm only changing successive copies of the map. And whoever gave me the original map can continue using their copy of it and so forth. And so it really makes a lot of things simpler to implement that way.
Mm-hmm. Can you talk a bit about how Clojure achieves efficiency with that restriction?
Yeah, definitely. The first thing that you would think of with that amount of copying going on is, oh my God, the garbage collector. You're going to be creating a lot of garbage. And that's partially true, but Clojure's data structures are based on what people call persistent data structures. Not persistent in the sense of being persisted to disk, but the idea that there's a lot of structural sharing that goes on. So when I have something that claims to be a list, it's not strictly implemented as a linked list. It's actually implemented as a fairly wide tree. And when I create a copy of the list with a new item consed onto the end or appended to the end, I get back a new tree root with many pointers into the old portions of the prior tree. So by the time we reach the leaf nodes, almost all of the pointers are the same and they're pointing to the same items in memory. This relieves a lot of the garbage collector pressure and makes a lot of these list operations very fast.
Mm-hmm. So I think you've mentioned two differences between Clojure and other languages. One is that it's actually full of parents. The other one is that it actually has these immutable data structures. If you were to name, I don't know, one or two other key features that you consider that make the language really different from other languages, what would those be?
I would have to name the transactional memory. So in Java, when you're doing multi-threading, you use a lot of locks. And so we're all familiar with wait and notify. In Clojure, we don't really use those. Instead, we control the point in time at which we change something, and we're typically only changing a reference to a thing. So Clojure includes a couple of constructs called refs and atoms. An atom is, you can think of it as a pointer to a value. I can dereference that atom and get the real value out. The value is then immutable. I can also change the atom by executing a function on it. So we have an operation called swap that calls a function with the current value of the atom, and whatever the function returns becomes the new value of the atom. This is how most applications manage their state, is with an atom. There are also refs, which have this aspect of being transactional. I can start a block called doSync. Everything in that block either happens or does not happen. So it acts much like a database transaction. And within the block, I can access a bunch of refs and I can modify a bunch of refs. They're all going to give me back the consistent value that they had at the beginning, and all of the changes get applied together.
So it sounds a bit as if there is a lot of very complex machinery hidden underneath that is exposed to give you a very simplified programming model. Is that a fair summary of the language from your point of view?
It's definitely fair to say that we have a simplified programming model. I can't actually speak to how complex the machinery is underneath. I suspect that somewhere it bottoms out in Java locks and monitors, just like everything else in the JVM, but it's not something that I've ever had to encounter as a user of Clojure.
Mm-hmm. In the sense of completeness, you mentioned that you got attracted to it, or one of its attractions was that it runs on the JVM, but it also runs on the JavaScript platform by now, right? Are you familiar with that one as well? Do you use it as well?
I have begun using ClojureScript mainly because I've been impressed with some of the amazing front-end work that colleagues of mine have done. I'm not myself a JavaScript programmer, so I can't speak to that aspect of it too much. I will say that Clojure and ClojureScript are best regarded as sibling languages. It's not precisely the same language on both platforms.
Mm-hmm. Okay. So one of the things that I find interesting and that we talked about when we planned this episode was that there are a lot of introductory podcasts and tutorials and articles on Clojure, and there is a lot of very, very low-level detailed stuff about intricate details, but there is not a lot of practical advice about how to go about building programs. So this is the topic that we agreed we want to dive into in more detail. So can you talk a bit about how you go about actually building a program? Maybe first of all, starting with the tool set. If you use Clojure, do you use your typical Eclipse IDE, or are you an Emacs person? Is the tool set different or the same to the one that you used when you were doing Java programming?
I'm an Emacs person, and so I tend to use Emacs for this. I did not use Emacs when I was a Java developer. I did use Eclipse then. I know the Eclipse Clojure plugin works well. I used it for 6 months late last year. And I also know that the IntelliJ plugin works exceedingly well. And I would say that those two are in a race for functionality and users. As for myself, I generally start with Eclipse and Nygard, which is sort of a automation tool in the Clojure space. Performs a lot of the same functions that you would find in an Ant or Maven type of build. So a simple Nygard file or project created from a template, that's enough to get me started. And pretty much the first thing I do is run a Repple, a read, evaluate, print loop. And this is probably the biggest difference in day-to-day workflow for a Clojure developer versus a Java developer. We get this interactive environment where we can submit bits of code, function calls, and definitions to the running Clojure environment that also has all of our application code. And so it's very common to see someone sort of iterating on an idea in the REPL. I'll start by capturing a data structure or piece of data that's going to be flowing around my program, and I'll just look at it and find out what type it is and what operations I can do on it. And I start putting together pieces of a function kind of one bit at a time, looking at the output as I go, building up a more interesting set of operations. And then I move that code into source files, put proper function definitions on it, fix all my awful temporary variable names, and really make it something that's going to be part of my application. So in terms of workflow, it's very iterative, and I tend not to do as much from unit tests as I would in a straight-up Java application. Where I write tests, it's more to nail down behavior that I want to last rather than the sometimes more exploratory tests that you would do in a Java project.
So is it fair to say that the REPL takes the place of a lot of the tests that you were using when you were doing TDD?
It definitely does. And I would say not only the tests, but it also in large part takes the place of a debugger. It's pretty seldom that I need to walk through code one statement at a time. Most of the time, if I want to debug something, I'll actually run the production code in the real application and capture one of the values into a variable, which I can then inspect from the REPL. So this is a common debugging technique where you put a little def statement inside of some function. Say we're building a web app. I put a def statement inside a request handler that captures the state of the request at that time. Then I go to the REPL and look at what that state actually is. So I don't need a debugger with a variable inspector because I have the REPL to look at all my variables.
So let's talk about those parts that make up the scenario. You have your running application, which is still something running a server socket on the JVM somewhere. Mm-hmm. And there's the REPL, and there is your Emacs or Eclipse isn't really that different in that regard, right? What runs where?
Yeah, that's a totally fair question. The REPL is just a way of interacting with the Clojure environment that your application is running in on the JVM. So I have one process which is running. We typically use Jetty or Netty. It's running that. It's got the application code, and the REPL is executing in that JVM. Mm-hmm. Then from Emacs or from Eclipse, you would connect to the REPL over a socket. So it listens on the network.
Okay, so it's actually two parts. It's the IDE that you happen to use and the running application that offers you the opportunity to interact with it dynamically or interactively, right?
That's right.
Back channel.
That's right.
Okay.
The REPL, it actually has a network protocol so that many of the different IDEs all have a common way of interacting with the Clojure environment. So hopefully we'll see better and better tools because they can all build on the same substrate inside the Clojure process.
Mm-hmm. So what you described is this interactive process that you're following, and that sounds like really the exploratory part of the whole thing, where you find out what it is that you actually want to build and try out new ideas and play around with what you have and maybe find a solution to a problem within your existing system. But how does that relate to design? How do you go about designing, a domain that's more than trivial? If you have, you have a I don't know, 25, you would have 25 classes in your domain model, in your bounded context, using all that terminology from the OO world. What's the analogy in the Clojure world?
I find that some of the approaches carry over directly, and some do not. So I spent a long time as an OO programmer, and that was the lens through which I viewed all problems and the whole world. And in that space, the layered architecture is sort of the standard approach, right? I would say when I started moving to Clojure, I had a number of conversations that sort of said, wait a minute, we're going back to data flow. Aren't we going to have all these horrible coupling problems that led to the creation of OO in the first place? Are we just recapitulating history from the 80s? And I'll say that is a risk if you don't impose some structure on your system. So we don't yet have a lot of, shall we say, application frameworks in the Clojure space. Every application sort of starts from a blank slate. If you're doing a web application, you have, you're going to have routes, and you're going to have a connector to HTTP. And beyond that, it's up to you to actually decide what the structure will be. So in doing that, I do go back to the notion of a bounded context, because I truly don't want my entire application becoming this interlinked set of functions that all know each other's data structures and the precise inputs and outputs. I create an area and say, within this area, all the functions are allowed to know that we're using a map with these keys in it, and that the value of this key is going to be a vector of pairs or something along those lines. But on the outside of that, no one's allowed to know the structure. There will be simple functions for looking up and creating instances of whatever my data is, and there will be functions for manipulating it. And if that starts to sound like objects, there's a reason for that. Those OO concepts of encapsulation and information hiding are still important as a means of structuring your program. What we don't typically do, though, is take the individual pieces of data and wrap them up in objects. And so we have this idea that says, use objects to structure your system, but don't hide your data behind this confined namespace.
So maybe, I don't think we actually mentioned this. I think it's important to know that Clojure is a dynamically typed language. So you do not have to create an explicit type for stuff. Of course, you don't have to do that in a statically typed language either, but it's sort of not common to do that in the Clojure world, right? You'd end up just using data as opposed to creating new data structures all the time. Is that a fair way to express it?
That is a fair way. I might also say Clojure provides a good set of data structures out of the box. Lists, as you would expect in any Lisp, but also vectors, maps, and sets. And it provides great functions in the library for manipulating those things. So in a sense, if you start to hide those behind an object boundary, you're tying an arm behind your back because you're giving up all of those built-in functions. Clojure does have, I would say, optional object-oriented structures, but you get them a la carte. So I can get polymorphic dispatch using something called multi-methods. So take all the OO examples of, bank accounts or shapes or dogs or whatever you like from the textbooks. All of those basically just do dispatch on their first argument, meaning, look up the class of the first argument and find the appropriate implementation for that. I can get exactly that with multi-methods, but I don't have to hide it behind a class boundary. So I can have a multi-method with a dispatch function that says, I expect a map, and I'm going to look for a key in the map called type or classifier. And then I'm going to have method implementations that each receive the call if their value matches the value that the dispatch function created. I'm not as great a communicator as Stu Halloway, so I'm making this sound much more complicated than it really is. The reason I call it optional OO features, though, is because I don't have to use multi-methods unless I choose to, and I can use them point-wise in different areas of my application.
Mm-hmm. So one of the things that I find is a frequent topic of discussion in this area, and let me put that to you as a question, is that maybe all this simplicity is just an illusion because it just seems simple because you're not doing anything real with it yet, right? You're just playing around. Of course, it's simple. Once you start hitting the real problems, you'll end up building something that's just as complicated as the stuff we have in other languages or other environments as well. Do you find that to be true, or is this simplicity preserved over the course of a project's life cycle? And what is actually the typical project life cycle of a project you do with Clojure?
In terms of simplicity, of course, you can optimize a language for making code samples on presentation slides look nice. But I find that it is something that you can carry through as you build an application. But it does require some discipline in order to do it. And so a very common pattern for me in implementing something is I'll do it the first time, realize that I've intertwined several different issues and created special cases all over the place, start pulling it apart into constituent functions that are decomposed orthogonally and each generalized. And then I realize that a quarter or half of those functions I created are just duplicates of library functions. And so they'll kind of, cancel each other out and factor out to nothing. And, the longer I work on a piece of my application, the smaller it gets and the more general it gets. So in that sense, simplicity is, I think, easy to achieve in Clojure, but it's not automatic. And part of what it really makes me do is appreciate the incredible amount of thought and careful planning and sheer good taste that Rich exhibited in creating the library. The second part
Rich Hickey being the
creator of Clojure. Yeah.
Right? Mm-hmm.
The second aspect of maintaining simplicity is that we just have smaller code bases to deal with. So we've got, I think, some pretty sophisticated applications running now. I'm just wrapping up a project that is an interactive development environment for games. So it manages all the assets of building a game, gives you graphical 3D editors running at 60 frames per second rendered via OpenGL, all of this using JavaFX, and it's got an extensibility model that will allow game developers on a project to extend the tool from within the tool in a very sort of Emacs-like way. All of that is still less than 40,000 lines of code. And so just when things are smaller, they can be easier to replace or rewrite or refactor in pretty aggressive ways. So that's another way that you can iteratively achieve simplicity, even if it's not necessarily there in your first implementation.
Mm-hmm. Would you dare making a guess on how big that code base would be if you'd build it in something else?
Well, I don't have to guess because the previous iteration was built on top of Eclipse. So the system we're replacing was deployed and worked. And that was about 250,000 lines of Java code in addition to Eclipse itself. The new version is not based on Eclipse, so it has to provide, all the things like maintaining a menu structure and knowing who to target with a cut, copy, paste command, those sorts of plumbing issues that Eclipse handles for you. And that all fits in the 40,000 lines.
Mm-hmm. And do you think that if somebody were to maintain that code base, could they take over from you, or does it have to be something like Mike Nygard who has to maintain that code base? What's the level of skill required to work with that kind of code?
I have a data point on that, which is that the lead developer on this from the client side started his Clojure work in January of this year, so 2015 at this point. By April, he was making very meaningful contributions, and now is completely poised to take over maintenance in the future. So he's not what I would call an average developer. He is a fantastic developer with tons of experience, and picked up on things very, very quickly. So your mileage may vary, but it's certainly possible to get people to adopt the applications and run forward with them.
Okay.
In fact, they've added someone to the team who I think took less than a month to go from Java enterprise background to working on Clojure in this graphical environment.
Okay, very impressive. So if I think of this is a kind of, I think for a lot of our listeners, this is kind of a unusual scenario, this game development environment. Even though it sounds extremely interesting.
Unusual for me as well, I have to say.
So let's talk about the stuff about the boring stuff that most people, including me, pay their bills with. These typical database-backed business applications that maintain some system record or some commerce process. Is that something that you think is a candidate to be built with Clojure as well?
Yeah, I definitely have to say yes, because the majority of our work is that as well. I think they're pretty good fits for Clojure. So let's talk primarily web applications. One of the big...
Well, probably everything is a web application these days.
Just about, yeah. Even desktop apps are really web apps in a container of some kind.
With a custom browser.
Yeah. So one of the things that we always deal with in web applications is sort of the layering into domain model and persistence layer and OR mapping and so on. And I would say we would tend to approach things in a pretty similar way, where we're going to have functions that are each responsible for dealing with some concepts in the domain. But instead of having those functions call through to objects which are supplied by a mapping layer, what we would tend to do is separate our application or the flow of a request into query, logic, transaction. So most Clojure web stacks, Ring and Pedestal and so on, are based on an idea of middleware, where a request arrives at the server and then it goes through some number of stages of processing before it finally reaches a handler that's going to emit HTML or JSON or whatever. And those pieces of middleware can check for authentication, check for validity of the request, and they can attach more state to this request map as it passes through the pipeline. So the request map has all of your HTTP headers, your request body, everything like that is all in there. And we may have a middleware that says, I expect the request body to be JSON formatted. So I'm going to parse the JSON string and then reattach that as a parameter and then call the next middleware function with the modified map.
So middleware in this sense is more of the rec terminology from Ruby or from Rails, right?
Yeah,
the idea of having, it's not the middleware in the traditional enterprise middleware sense. It's more a little piece of a little function that enriches or modifies, mutates the request as it flows through the processing pipeline. Is that correct?
Yes, that's exactly correct. Thank you for that clarification. I was not thrilled with the choice of middleware for those functions, the name middleware, but
yeah, for some reason that happened. Probably somebody didn't have the negative connotation with middleware some other people have.
So
sorry for interrupting.
No, that was helpful. So we would put more middleware in the pipeline that would say, for this type of request, I'm going to go look up the data that I need from my database, whether that's Datomic or whether it's a SQL database or something like that. Then I reach a handler function, which just operates on data. So it gets a map in and it emits a map out. This makes it incredibly easy to test. When I'm at the REPL, I can call my handler function directly and just pass it a map and look at the map that it gives me back. I don't need to mock anything out. I don't need to stub out the database. I don't need to have any kind of fake ORM or in-memory thing. I just call my handler. So this lets me isolate things in a very nice way. What I get back from the handler then is another map. That map will typically have new values attached to it that I want to transact back into the database. And so in Pedestal, that would be another function on our what we call interceptors. That's the same as middleware, really, but it would be the exit handler.
Can you briefly explain what Pedestal is?
Yes, sorry. Pedestal is a web framework for server-side applications created by Cognitect.
Okay.
It's pretty equivalent to Ring, but allows some nice features for server-sent events and asynchronous or streaming responses. So we've split the call stack. Instead of just having, a call down to the next layer of middleware and then the return stream coming up, you can actually have completely separate functions for enter and exit on requests. But you can do the same thing in Ring middleware. You call the function below you, bind the return value to some name. You can then manipulate that, do your side effecting stuff that changes the database, and then return it upstream for further conversion into HTML, or again, JSON or XML or whatever else. So where in a typical layered application, we're sort of drilling through all the layers, and once we've called into the domain calls into persistence, and you have this separation into service classes and sort of domain concept classes. We would split that differently and say the middleware calls persistence, then it calls my business logic or domain logic, and then it calls persistence again, bracketing it rather than having it drill through.
But as in a DDD scenario, your business logic is entirely independent from your choice of persistence mechanism or UI framework or whatever delivery mechanism it is, right? It's the same key idea that you have this thing that is pure logic and not tied to anything else.
Yes, I like to draw the domain as the center of concentric rings or the middle of the hexagon rather than the middle layer in a stack.
But don't you lose something? I mean, if you have it this way, the way you described it, and I think that's a perception many people have, is that it's really just data that's put into some functions, and then there's new data coming out of it, which is, of course, what all computation is. I'm aware of that, but it's really very explicit because it's just data. It's not explicit. It's not typed. It's just as if in Java you passed everything by means of hash maps that include hash maps, that include lists. And in Java, I would not consider that a good Java design. I would say, well, actually, in Java or in any other OO language, you are supposed to make your domain language explicit by creating the classes and methods and the relationships and whatever it is that makes up your specific domain, and give them names, make them something that has meaning within the language. That's not something you can do in an untyped functional language, right?
I dispute that you can't do it, but I agree that it's a useful thing to do. And let me unpack that a little bit. So one of the things we always talk about is objects should be able to maintain themselves in a valid state. It should be impossible to put an object in, to do an operation on an object that renders it inconsistent or nonsensical. But very often the notion of validity is context dependent. So I've often run into situations where, say, I'm accepting data from a user and populating some domain object. I want to ask if it's valid. We put a validate method or an is valid with a Boolean return. The problem is the notion of validity for saving to the database may be quite different than the notion of validity for, sending to a channel partner or exporting an item. I've done a lot of commerce work, so I'll use an example from there. If I'm creating a new item in the catalog, I may need to give it just the barest amount of information in order to first save the item, and it should be valid to save, even if it's not valid to publish to the website. So the notion of validity is very context sensitive. And we find that with almost every operation that you want to do on an object. I think this is one of the reasons that creating enterprise object dictionaries is so hard, for example. So much more often, I find that I can create a notion of conceptual integrity in good function naming. So, this may start to sound like I'm just recreating OO as a naming convention. But I get the functionality that I need by naming functions in my model that take data in and give me back well-formed data out. But I can then use them a la carte. I'm not forced to use them all the time.
Mm-hmm.
The other way that idea of objects breaks down when you start using it for your domain data is that sometimes there are purely structural manipulations I want to do that really don't have any domain concept attached to them. So in LINQ, you can run a query and then get a projection back of the results, or a subselect of the columns. And that type, we don't name the type of the result that you get back. It's a set of tuples because there's no domain concept that says I only want these two fields from all of these rows. So if you've ever had to create a summary object, you want to display a list of all the candidates before you pick one and then get the detailed view, right? You create a summary class and then you have the real class. And often, if you need business logic, you start duplicating it, or you realize the summary class exists only because I need some set of named fields. Well, you can just do that with a data structure. And then again, you get the benefits of all the built-in library of functions.
Okay, so what you're saying is there's a lot of functions that just operate on these generic things, and you can use them as opposed to creating specific stuff where you have to build the stuff again, right? Was that the last point?
Yeah, the idiom or the colloquial saying is it's better to have 100 functions on one data structure than 10 functions that each operate on one of 10 data structures.
Mm-hmm. I actually share that experience you mentioned before. The code becomes smaller all the time once you work with it, even though to me this typically happens when other people look at my Clojure code and they point out how I missed using one of those generic functions. And sort of my code shrinks every time I talk to an expert who helps me make it even smaller. I think many people have seen that this naive approach of just trying to create a single object model breaks down very quickly, which is why you end up with more complex object models with validators and I don't know, other classes that implement certain patterns that just help you to distribute all of the functionality across the different concepts and to isolate and decouple them. And I can sort of see the analogy to just having a huge set of functions that address the same aspect. But what about the typing aspect? Isn't it the case that if you are using an untyped language like Clojure, you have to do a lot of the type checking that a statically typed language would give you for free yourself in your own code? Don't you spend most of your time just catching type errors?
I definitely encounter type errors. Don't believe someone who says they don't. They just don't recognize them when they're encountering them. So for me, a really common error that I make is I try to access a key from a map and the key doesn't exist in that map. Well, a Haskell programmer will tell you that's a type error. And I agree, it's a type error. I have used that map as if it's something else.
Mm-hmm.
But I'm willing to make that trade-off because I find that I'm sufficiently more productive with those type errors than I would be with making the type system work for me. The other aspect is there are certain types that are represented and that I can ask about and do different things based on the type, but they're never concrete types. So I have predicates in Clojure like, is this a vector? Is this sequential? Is this a collection? Is this associative? Is it map-like? Can I access it via keys? Those are all asking against interfaces. And so, if I'm asking if something is a set, it may be a sorted set, it may be a hash set. I don't really care. And that's a good guideline for any new types that you would create. So we've got a construct in Clojure called protocols. And I haven't mentioned these yet because they're kind of a more advanced topic, but this is probably an appropriate time to bring them up. A protocol is analogous to a Java interface in that it's a collection of signatures with no method implementations. In Clojure, I can build new types that reify those protocols or that implement those protocols. But I can also add an extension to any existing type and say how that existing type supports this protocol. And you can even extend a protocol to nil and say, how does nil respond if I try and dispatch a protocol to it? Which is a little bit of an odd notion. Nil is not as immediately deadly as null is in Java. Danger, put yellow warning road signs around that concept. Don't use it unless you really, really have a reason to. So when I have one of these protocols, I know that I have a set of functions that I can dispatch to any value that implements that protocol. And I can make a map implement a protocol. I can make a vector implement a protocol. What I usually find, though, is that the protocols are very, very narrow and very specific. So if you think about the segregated interface idea, Clojure protocols tend to follow that pretty carefully, meaning I group together a set of functions not based around what the supplier knows that it can do, but based around what I want a consumer to know about this thing. So, for example, one of the core abstractions in Clojure is the notion of sequence. Now, this one's not a protocol, it's an interface, but that's an implementation detail at this point. The sequence simply means, can I ask for the next thing after the value that I've got? That's it. That's the entirety of the interface. Can I ask for next off of this thing? And there are many of the core library functions that are written around sequences. So if you can convert any value in your domain to act like a sequence, then you get the benefit of all of those core functions. If your value also implements other protocols, then you can use it in other ways. And so you can think of these protocols as very narrow projections to say they're homomorphisms to confined domains, but they're very narrow projections of behavior.
So that seems similar to having lots of very small interfaces in Java that just have as few methods as possible and just capture this one aspect of something.
Yes.
Right? So that you end up with those classes that have lots of little interfaces, implements, collectible and sortable and whatever, comparable, whatever it is, all of those small little tiny things. Seems like a very similar thing, except that in Clojure, you'd have to do the check yourself before you call something, right? There's nothing at compile time that'll prevent you from exerting an expectation that's invalid, right? You have to somehow know or check that these things are okay, because nothing checks for you at compile time.
That's correct. Nothing checks at compile time. Building the check into the receiving function is the typical way of doing that, and this isn't as widely used as I think it should be, but every function can declare preconditions in a sort of design by contract style. So you could attach a pre-metadata to your function that says, this must be a line item in a larger record or whatever. So you do have that option. But yes, it is something that you would check for yourself.
Okay.
Again, it is a sacrifice that the compiler does not catch certain types of errors for you. But I'm comfortable making that trade-off because I gain a lot via the REPL and basically, not having to pay attention to the compiler and all the other situations.
Typically, it's me who has to justify himself for liking dynamic typing. It's fun to do this to other people for a change. Do you have any experience with typed Clojure? And if so, can you tell us what it is?
I'll start by describing what it is. Typed Clojure is an effort to add, via libraries, add typing to Clojure itself. Type inferencing as well as type checking and enforcement. It's been an ongoing project. I've been watching it with considerable interest, but it's not clear to me that it is even theoretically possible to succeed without constraining certain features of Clojure itself. And this goes into language theory that's not my forte, so I'm relying on opinions from other experts who know what they're talking about better than I do. I have only looked at it and dabbled with it. What I found was that it imposed a pretty heavy compile time performance penalty. And the project where I was looking at it is one where we needed to compile interactively, so we had to back away from it pretty quickly. I didn't make a serious effort to embed it. There is a similar project called Prismatic Schema Prismatic is a company. They do a social media or social news aggregator, and they're based entirely in Clojure. And they built this schema library that lets you declare the shape of the data that you want to work with. So instead of saying that my functions are typed, I'm saying that the data is typed. And I can declare the structure with basically the shape of data structures is described via other data structures that we know to interpret as schemas. I've used that.
Sounds a bit like XML schema and XML.
Well, that may trigger some unfortunate associations. It's not as verbose or painful as that. No, really, if I want to say that some value should be a vector of strings, I put bracket string as the schema annotation on it. So the bracket indicates vector. String is actually just a reference to the Java class, Java lang string. So that's how I say that this value needs to be a vector of string. Then I have the option to apply validation or not. So it's common to turn validations on when you're running tests, for example. And then you can get exceptions thrown if the values being passed in don't match the schema. And the exceptions are actually quite nice. They're very precise in telling you what's wrong with the value that you've passed in, even if it's 3 layers down in a nested map. But you don't have to incur that penalty all the time. So we can turn it off for production code, or we can actually just call the validate function directly in places where we need it.
Mm-hmm.
So again, one of the concepts that I really like in the design of Clojure itself is all these things that are bundled together in other languages are sort of pulled apart into their constituent features and made optional and a la carte.
Does that extend to the library ecosystem, to the library versus framework debate? Is it more that Clojure does libraries where other languages do frameworks, or is it this just a core language kind of thing?
I think there's a community style that says we should favor small composable libraries over frameworks. That started quite early in the Clojure realm and has continued even as the community of users has grown by a factor of 100. I don't see anything acting to change that toward a preference for frameworks. But I will say the libraries are not always as composable or as plug and play as the aspirations would indicate.
You mentioned the growth in the number of users. Are there other well-known examples of Clojure users other than Prismatic? Can you name a few?
I can name a few, actually. Probably the largest company that I could name that has adopted Clojure in any significant way is Walmart. They started last year with a program to capture receipts from every point of sale terminal in every store. It might be kind of surprising that they weren't doing this before, but the data pathway was very long and tortuous to get into a warehouse and then into data marts and then out. So they're actually capturing data as it's being sent to the receipt printer, reparsing it to build this database of what they call e-receipts. The first application they built on top of that was something called Savings Catcher. That was built in Clojure and rolled out and part of national and maybe international advertising campaigns. Savings Catcher means if you have missed out on a coupon or a competitive deal or something like that, then right at the point of sale, you will get an instant discount for it. Mm-hmm. And that was built largely using Clojure for the data aggregation and plumbing and roll up across all of those 5,000 some odd stores.
Mm-hmm. How does one manage to sneak something like Clojure into such an environment? I mean, Walmart, well, maybe not this. We don't have to talk about this specific example. I don't know how much you know about it, but just in general, what's your experience? Do you have to have a scenario where the client or the management just doesn't care, or can you actively convince decision makers that it's a good idea to bet on this rather unknown language?
I've found an incredible mix across the environment over the last couple of years. It turns out that there are a lot of closet Lisp enthusiasts, and many of them have been around long enough that they're in senior positions, and so those are the very easy ones to convince. They saw the parens years ago and fell into the blue void of Lisp. Others, I would say, because I work for Cognitect, a lot of clients come to us already interested in Clojure. But I've had some other conversations. A very common pathway to get Clojure into an environment is via non-production code, particularly tests or automation of some kind. And because Clojure is very nice for working with data, you can use it to handle a lot of internal data processing chores and get things done quickly and gain attention that way. In terms of getting into production, there was an idea a couple of years ago that said, well, it's just a jar file, so as long as it's running on the JVM, nobody really needs to know, and you can just slip it in. I don't necessarily consider that a very team-oriented perspective or a healthy way to deal with your organization. But I would say, being open and transparent about bringing it in and describing the advantages, and then being ready to back it up with assistance. And this is a crucial part. If you're going to be the champion for bringing a language into your company, you need to be available to people to help them solve their problems. Because oftentimes, when they come at you with a problem, 50% of the approach they take is about the problem and their inability to solve it, and 50% is either a veiled accusation that it was a bad idea, or maybe you perceive it as a veiled accusation that it never should have been brought in. So you have to be prepared for that.
Mm-hmm. How much of a burden do you leave for future generations when you build something in Clojure? Will it be easy for somebody to pick up, or how good do you feel about doing this? How confident are you that it's going to stick around for the long term? Maybe that's the wrong question to ask, but I'm still interested in your answer.
Sure. At this point, Clojure is 6 years old, I think. So
something like that.
So it's already been around for a while, and it doesn't show signs of withering. In fact, the community is growing year over year. But I will also say, we need to consider the shelf life of applications in the context of your company. If you're a startup or if you're in the web space, there's no point in building something that you expect to last for 5 years. Nothing's going to last 5 years in your startup. So you're already prepared, I hope, to throw everything away and rewrite it multiple times. Mm-hmm. In a larger enterprise, here we risk veering into the territory I spend most of my time talking about. In a larger enterprise, you do have to be concerned about time spans like 5 years, 10 years, and so on. And so, good architecture comes into play. I hope that you're building your systems in such a way that different pieces can be replaced at different rates and at different times. And this would be like everything else. It's another box with an implementation inside the box, and it may get replaced. It's just the nature of things. I'll say another one of those sort of toxic ideas is when somebody comes in and says, well, this stuff is okay for me, but my colleagues would never understand it. And so, first I have to replace everyone else in my company but me, or something like that. It's simply not true. There's no magic to this. Lisp is not inaccessible to mere mortals. The parentheses do in fact disappear, and you quickly see the structure of the code. And having the REPL there is an amazing learning tool. It's like going back to the 8-bit days when you booted up into BASIC and you could just do stuff immediately and see what happens. So people can learn it pretty quickly. I'm not worried at all about leaving something unmaintainable behind.
Mm-hmm. Okay. One of the things that I've always liked about the Clojure community is that there are so many great things to learn from, and so many talks and books and online resources and stuff like that. What are your favorite recommendations? Where would you point people to who want to find out more about the language and the ecosystem?
There are a ton of talks on YouTube now from several years worth of conferences. So you could spend days just watching videos on amazing and cool things people have done. Clojure TV is the channel there. Mm-hmm. I also think we've got some excellent books. The sort of first round of tutorial books are now out of the way, and we're starting to get books on, okay, what do you do for day 2, and how do I live with this long term? One of them is called Living Clojure by Karen Meyer, and another one that I think is in early access now, but will probably be final by the time this airs, is Clojure Applied by Alex Miller and Ben Van Grift. I think those are both excellent books for learning how to do things that are going to last for some period of time and learning how a real project goes beyond just learning the language.
Okay, good. We'll put all of those resources as well as other things we mentioned into the show notes. Do you have any parting last words to future Clojure users?
One more thing that I would mention that I haven't done before. Java interop from Clojure and JavaScript interop from Clojure script were both made incredibly simple for a reason. There's a strong temptation when adopting a new language to rebuild everything in that language. Mm-hmm. But you're on the JVM with all the billions of dollars that have been invested in software there. So embrace that and go ahead and use the libraries and use the core that's already there. Don't reinvent the wheel. It's a waste of time and money.
Okay, Mike, it's been a pleasure having you on the show. I enjoyed this very, very much. Thanks a lot for spending your time with us.
Thank you. Happy to be here.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio Group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.